What's up guys, Embedded Monkey here, and today is Embedded Adventure Day 15, Um, in previous series we actually made an LED blink again. So what is the difference with first LED blink, which we have made here? You can actually check this out, that was pretty awesome. Spoiler alert, we used timer interrupts, so if you want to check how to implement that or to check how I managed to implement that, you can check this out. But today, I guess we're gonna do some theory stuff. So today, today's video won't be that epic. So basically, I just stick with this plan because I'm currently still consider myself a beginner in embedded systems. Despite the fact that I have already made an LED blink, of course, yep, so kind of beginner, you know. But currently I have a lot of topics to explore, because, you know, I have like two main goals for this adventure. Like the first goal is to do a cool project, and we actually, in one of the series, I don't really know in which of them. I guess in this one, in day 10, we actually chose the few ideas that I actually like for project. So it'll be either a gaming console or smartwatch or a musical instrument or walkie-talkie, I don't know, because these ideas are actually cool. But with all these projects, I also want to actually find a career path in embedded systems, and this is where you have to learn a little bit more about theory and dive deep into some topics. So in previous, I don't know, 2 or 3 series we covered these topics. I guess I will explore some ADC, DAC today. Yeah, GPIOs, I actually know a lot about them, so I actually checked the technical reference manual, and I read all that stuff. So if you want guys for me to make some, I don't know, handwritten notes for that, I actually will do that as soon as I have enough time for it. Okay, but today I guess we'll just stick with ADC and DAC, and of course I will talk to my mentor, which is here, and ask him to guide me through that topic. Not to actually spoil me everything, because that actually won't be interesting, but to let me step by step go through that topic. So without let's go. Okay. So yeah. Can you guide me a little bit? That's funny how videos actually become just chatting with ChatGPT, but actually that's useful. My main goal is to learn, not to just create some epic videos. I know that epic videos are cool, but nevertheless, not every day, definitely, because not every day I have like enough energy, but still we should remain consistent and do at least something. Okay, so esp32 is a great platform to learn ADCs and DACs. So actually, what is ADC is analog digital converter, and DAC is the opposite. It's the digital analog converter, which converts different signals. So ADC converts analog voltage to digital number. Yeah, as we all know, it's used for sensors and for reading voltages. So basically, the ADC is for inputs. Am I right? Like, for example, we read the some analog voltage from the sensor, convert it to some digital number, and use it somehow in DAC, like digital value to analog value, audio signals, control voltages, and simple waveform generation. So basically, this one for output, this one for input. Guess something like that. So basically, ESP32 has two ADC units, ADC1 8 channels, ADC2 10 channels. ADC unit, like, you know, I thought, like, I saw that thing on Random Nerd tutorial where there were like pinouts of the ESP32. I'd just like to see that picture again. I thought that was like in very first article, where they said that, yep, here, ESP32 pinout reference. So, well, it actually tells us only different features of each pin, not how the signal goes there. Like, there's a DAC pin, for example, yep. But I guess that basically means that, like, this pin can take the digital signal and convert it to analog, or is it just outputting the analog signal? There are also some ADC signals. Okay, we'll ask about it. Okay, so if Wi-Fi is enabled, ADC2 cannot be reliably used. Interesting. ADC resolution, ESP32 ADC is 12-bit. So that basically means that we can encode 2 to the power of 12 minus 1 values. Yep. Each step is 0.8 millivolts, I guess. Yeah, so basically, okay. Like, I'm gonna just draw again. I just enjoy the drawing and all the stuff that I'm trying to understand. So, for example, we have some signal that goes like through the time. Yep. We got the, like, I don't know, some periodic signal. Yeah. So, and basically, for example, these values, I don't know, like, well, say U1, this one value is like U2, not YouTube, but yeah, U2, yeah. So basically a voltage, yeah. I don't know, guys, by the way, how in, like, your, maybe system the voltage is, like, with which letter voltage is signed, but I guess usually we use just the letter U, so probably, yeah. Basically this converts to some, well, it depends on how much of the difference here. Yep. Okay, I'm gonna just ask. So, am I getting this, like, how, okay, how ADC works on electronic level? Say we have some electric analog periodic signal of changing voltage, of of periodically changing voltage. Yep, periodically changing voltage, how it is actually converted. Mixed signal electronics at work. Yeah, good. It's cool to know API. Like, for example, with interrupts and timers, in the end of the day, it's just basically copy pasting from documentation or ChatGPT, as you remember. Yeah, we're just using standard calls, but to actually understand what do they mean, like why do we do certain things, it's important. So there was a very accurate statement. I would say. Yeah. I'll explain this from the electronic circuit level step by step using a periodically changing voltage, like a sine wave as the example. Okay. Explain. Sorry guys. Okay. What an ADC must do. To convert an analog voltage into a number, an ADC must sample the voltage at a specific instant in time, hold that voltage steady, compare it against known reference levels, encode the result as a binary number. It's done with capacitors, switches, comparators, and digital logic. Yeah, I actually remember. By the way, let me find the. Maybe I have the notebook left with some notes from electronic course that was in my university. Probably I have some. I guess that's pretty interesting. Yeah, I found it. The dark side. The dark side with some funny bird. Yeah, I guess I have the notes about ADCs. I just don't remember completely because I don't use it like on everyday basis, but probably I can actually find some information, and I'll show you. I'll show you guys, because that's pretty interesting. One moment, guys. There was like 1.5 years ago, but I actually wrote a lot here. Okay, not that one. Some transistor thing. I guess there was some material. Okay. Well, or no. Maybe I have skipped this lesson. Actually, I haven't remembered. But okay. By the way, if you're interested, I can also scan that thing and maybe upload it to my to my Google Drive, if you want. But yeah, I probably won't be able to find it. But somewhere I have already heard about ADCs and DACs. I just can't remember how they work exactly. So we are sampling. Sampling means that we are dividing that signal by the time with some step. Yeah. Continuously watch this signal. Instead, at precise clock intervals, a switch closes. A small capacitor is connected to the input. The capacitor charges to the input voltage. Okay, so this is called sample and hold. Electronically, CMOS transmission gate is switch and capacitor holds voltage. After a short time, switch opens, capacitor freezes that voltage. This is crucial. The ADC works on snapshots in time, not the continuous wave. Okay, so by the way, ADC circuit. No, that's like input voltage, counter control. Well, I guess it actually can work, but I want to find the circuit that uses just the capacitors and switches and all that stuff, like, I don't know, ADC circuit with capacitor. It seems like that was drawn by me, but no, I actually haven't drawn this. Oh, I guess here we go. So every like sample time we close the switch. Yeah, you know, let's just abuse ChatGPT. Can you draw the, not the draw the ADC circuit with capacitor? Too long. Okay. Okay, let's just continue with the next step. Now we have a held voltage on a capacitor. Let's assume reference voltage is 3.3 volts. Resolution is 12 bits. Total codes. Yep. Each digital step represents okay. So the ADC must answer which of these 4096 voltages bins does this sample fall into? Oh, that's basically what I thought about. Like, so we basically quantize these values. Yep. So we took a no. We actually here we go. We took a snapshot here. Yep. So we got this value. This is an analog value, and we actually divided by some value, for example 0.8 millivolts. I guess these are, or millivolts, 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 micro. Guess it's like milli. Yep, so 10 to the power of -3. Yep. And which, oh no, we actually reference. So okay, how does the ADC decide the number? There are multiple ADC architectures, but the esp32 uses a SAR-ADC, successive approximation register. Most common type in microcontrollers. Okay. Sample and hold capacitor, comparator, DAC inside the ADC. An ADC actually contains DAC internally. Okay. By the way, let's still creating an image. It's pretty long. Okay. I hope it'll create until the end of the video. Yeah. Okay. So we create the ADC have some comparator. Yep, it should have some comparator that can actually determine like which of these voltage bins does the sample fall into. Say the number, there are multiple ADC architectures, but the esp32 uses a, so yeah. So imagine 2 volts sets output to 1.65. Comparator checks, does this more? Yes. Binary so far. DAC tries. This one. So every bit is basically an increment in voltage in such value. Is it like fixed voltage value or something like that? "12 comparisons. By the way, let's take a look at the normal schema of the ADC circuit. So first of all, we got the 0 level, so the DAC outputs 0. Since the counter have 0 level, we compare it, this voltage with 0. And of course, well, by the way, let's just read this article instead of just trying to understand GPT thing. Oh yeah, I like privacy. I just wanna unclick all cookies. Yeah, all cookies. I'm not lazy. I'm just like I just like privacy. What a world we are living in. Confirm choices. Okay. Display the positive. The output of the comparator is high. By the way, what does the comparator does? Like, does the comparator outputs us the value that is maximum between both? Like, comparator circuit. Like, how does it work? Pairs 2 input voltages and outputs a digital signal, indicating which input is larger. Okay. Which or the voltage of this input? Essentially converting analog differences. High, low. So it outputs a digital signal, like if it was higher, if like the first, if like the positive input was higher, it will output 1, so the high voltage. If it was 0, if this one was larger, then it will output 0. So first of all it will output 1, AND gate will generate 1, and counter will count up to 1. Okay. Then we save this value to latch. It can be, I don't know, some register, something like that. Then it goes to DAC. Then the DAC, I guess it just adds up the needed voltage. Yep, it allows. Then starts counting the clock pulses. The output of the counter is fed to DAC, which computes the decimal equivalent of its binary input. Now the output of DAC increases in a staircase fashion, and it is continuously compared with the input VIN as long as counter keeps counting. At the moment, okay, the comparator output is low, and AND gate is disabled, therefore blocking the clock pulses. Also, the control block notices the transition and puts a low signal in the clear pin of the counter, thereby resetting it. Simultaneously, the last output of the counter is latched, and this is the digital binary output of the given input voltage. Okay. Well, it seems logical, but for some reason I can't understand, like, why should it work? Like, where are the guarantees that DAC outputs the, like, correctly increments the voltage, or something like that? Well, it's better to know how the DAC works now. Is there any explanation? No. Okay, maybe like how DAC works, or just DAC circuit. DAC circuit. Okay. Hell no. Oh, hell no, I mean. It's like a weighted register. R to R letter. Whoa. Guess that there are plenty of things to actually understand before I actually can code anything with ADC's DAC. Well, usually the microcontroller just holds the logic of ADC and DAC for you, but it's much cooler to understand how they actually work internally. Yep. But probably this one seems very well. I can actually understand it probably, but should have some time. Okay. All right. Yep. ADC. Damn, it's still creating the circuit. Oh my gosh. It's created. So we got the analog input signal, sample hold circuit, then it's done with the capacitor, then it goes here. Well, this one is actually, if we replace that block with the block that we actually discovered here, then it can be true. Probably, yeah. It can be true. So, seems interesting. Seems interesting. Okay. Nevertheless, guys, currently I have a lot of studying to do this week, so probably I should end this video now. I will continue to do at least half-hour videos to actually learn something in the morning, like for this week, but I guess this week is pretty hard for me, you know, like the end of the semester, and I should do my diploma as well. So if you enjoyed this video, hit the like, I don't know, subscribe, leave a comment, and I just want to thank you guys that you follow me. Like, that's incredible, guys. Yesterday I thank you for 50 subscribers, and in one day it's already 60 subscribers. Damn. I hope I motivate you somehow to learn embedded systems. I hope that would be cool if you, like, you know, share all your thoughts, all your like ideas and comments. Maybe there is something cool that you know about embedded world that I should learn. Maybe you have some suggestions. That would be cool too. And just thank you guys. Yeah. See you tomorrow in Embedded Adventure Day 16. Yeah. Have a great day. Bye.